Welcome back to the MVA on Microsoft Blockchain as a Service. We're going to wrap up with Module 5 here on the development of decentralized applications. So we're going to get into my favorite area where we actually get into some code and actually working on some things here now.
Yay,
actually
code.
Building something.
Yes, less theory, more code.
So again, and not to beat this over the head, but I'm going to show this slide again one more time. We talked about this in a previous one, but basically what I want to talk about here is understanding a day in the life of a developer of a decentralized app.
Okay.
So when he comes in to actually build an app, there's nothing special about the actual application itself.
It's just
right?
code.
It's just code, right? So it could be a web application, it could be a client application, like a fat client. It could be anything that we built our application platforms on to begin with. It could even be a UWP application, in Windows. So we can think about, from that perspective, it's just an application. Once we start talking about the back end and where we want to actually concentrate, and we talked about a lot of concepts about, thinking about storage and what we need to store in the blockchain versus what we want to keep off-chain. Once we kind of figure out, okay, these are the core things
the architecture.
that are important. Yeah, the architecture around what's important, what do we really need to store on the blockchain, that we need that immutability, that we need that shared aspect of it, and those kind of pieces. Once we determine what that is, then we can sit down and start building that. And I actually see this functioning as like two different developers, but it could be one. And I've actually seen this play out in actual hackathons in the real life, that we would sit down to build a dApp. Well, somebody has to build the actual smart contract, and then somebody has to build the dApp. And there's a lot of work to do on both sides. So we basically divide and conquer, and we would have a group of people just building the smart contract. And they would exercise it through debugging tools. We'll talk about some of those. And then the developers over here working on the actual front end.
Okay. Okay. So in this instance, you separated what we were previously talking about dApp as the whole thing. Yep. You're separating out that it could be an ASP.NET, MVC, a UWP app that those guys are working on, and then behind the scenes working on, and I call it the middle tier, but it's not necessarily the middle tier. It could also be the third tier.
Yep.
Those guys are the ones that are writing the smart contracts, and there's specialized tooling that is available that you're going to talk about, hopefully.
Yeah, and it's important to keep in mind that these tools can work together, right? So it's not that everybody has to use the same tool, right? So the people writing the smart contracts could be using Ethereum Studio, and the people who are writing the front end could be using Strato BlockApps. I mean, these things work together, basically, because the smart contract is portable code.
Okay, so the soul file, that solidity, that is the common denominator across all of this stuff.
That's correct. The only thing you have to keep in mind there is public versus private. There is some differences between those, but there still is carryover, right? We could develop something and then test it and put it up in testnet, make sure that everything works, and put it in the public network.
Okay.
Or we could develop it just for private network, whatnot. So.
But it's also important to remember that the code that you write, again, going back to Module 1, is the epitome of open source. Is you put it out on the public net, anybody can decompile it and look at what you've done.
Correct.
Okay.
And in a private sense, obviously, there's some shared trust there.
Sure.
So I'm working with Derek in a B2B scenario. Yeah, he can see my code, but we've already kind of negotiated on it. So in that case, maybe it's okay.
Okay.
Because we're not sharing it with the world. I'm just sharing it with my business partners.
So what kind of frameworks do we have to help kickstart this stuff?
Yeah, so I look at this as like there's basically three different kind of buckets that I'll fit these things into when you start working for this as a developer. The first one being the frameworks. So we mentioned some of these guys as in passing here, but Truffle being a good one for a dev platform. Ethereum is one that basically takes, and I'll pull back here a second. The primary one for working with Ethereum blockchains is Web3.
Okay.
So Web3.js, there's also a Web3.j for Java. These are kind of the industry standard for interfacing with blockchain.
Okay.
And when you're talking about just pure Ethereum, like just talk about it from that
But
sense.
I want to write .NET. What capabilities or tools do you have available for me to write my C# code?
Correct. So an Ethereum is what's filling that gap,
Okay.
right? So Ethereum came along and built basically an interface to allow you to write C# code and do functions that Web3 would be doing.
Now, is it a native port or is it just a projection?
It's a native port,
Okay.
so they actually built a thing.
Okay,
Yeah.
cool.
So BlockApps is a totally different framework. We're going to talk about that in some of our demonstrations. But the BlockApps is a kind of a totally different mindset. So when we've been talking about blockchains with Bitcoin and Ethereum and these things and private Ethereum, BlockApps actually took the concept and said, when you're working with one of these blockchains, I mentioned Web3, it's called JSON RPC that you're actually going to be the protocol that you're using to communicate with the chain.
Right.
And I don't think, just off the top of my head from enterprise sense, not a lot of people are writing JSON RPC code if they're not working with
It's pretty old
blockchain.
school. Yeah.
So in that sense, it's a new protocol, so developers have to kind of get up to speed with it. There's a lot of kind of boilerplate code you have to write to kind of get these things running.
Just a bootstrap, yeah.
And when you look at what BlockApps and what their Strato product did, what they were saying was, let's put an API in front of that that allows it to make it so people who are familiar with web development, REST-based web interfaces, let's give them a REST-based web interface and allow them to do transactions, accounts, all the different operations against that. And so that's what their kind of play is with Strato, and it actually works really well.
Okay,
so when you're getting up to speed with this, I recommend checking that out. It's pretty easy to get going, but yeah, it's kind of totally different from the other chains that we have there. Tendermint is another one that's out there. I mentioned a bunch of these. We don't have to go into the details about them, but they all kind of have a little twist on what they're doing. Tyrion being a proofing engine. So these all have really unique features that they're bringing to the blockchain space.
Yep.
From a and then you talk about development chains. I mentioned before that when you start working with this, you probably don't want to go stand up whatever your production environment's going to be and start developing on top of it. That's not even how we do regular development. We usually start at the developer.
Right. Or just on their desktop.
Exactly. So very small space. So what can we do to do that? Well, Strato offers a thing called instant mining and allows you to do a dev chain where there's just one node. That's great because you can see things go really quickly, to your point about async. Developers don't want to sit there and wait for consensus to run. We know consensus works. We know the algorithm works. All we want to do is just test our smart contract and make sure everything works. So that's one way to do it. Chain has a really nice interface to allow you to start building on top of their platform in that way. BigChainDB is a different animal. So that's a different product that basically emulates some of the functionality that a blockchain gives you, but they're using some different technology to do that. They have a database behind it, and they do really high throughput transactions.
Yeah, they're trying to bring the best of chains and the best of databases and smush them together.
Yeah.
Okay.
But I think you could composite these together as you're building your dApp. Don't feel that you're limited with it. Okay, I'm working with Ethereum. That's all I can do. You could actually have modules and things inside your application that do things like if there's an area where there's high throughput, maybe you do look at something like BigChainDB to get
that. Was one of the things that was really challenging for me when I was getting started. I put up a Geth node and I started slinging Web3 and JavaScript, and it was all really, really hard to do. But from listening to you speak at different conversations, different conferences, learning about how I can use Strato for some things, I can use good old Go Ethereum for different things, Truffle to make the framework and the tooling easier. So you have to bolt on a number of different parts.
Yeah, and I'd say that's kind of a pro and a con. It's really good because the communities behind these things are very passionate and they're building really good products, and it's happening very fast. On the same token, it's very fragmented.
And it's happening very fast.
And you have to be kind of plugged into this ecosystem.
Right.
It's like every day it seems like there's another framework that's coming out, and you're like, okay, what does that do? Like, is it different? So I think there's heavy fragmentation there, but I don't think that's necessarily a bad thing. I think it's kind of starting to come up to something better now.
Absolutely. And of course, there's a lot of tooling available for you to use these frameworks and these dev blockchains. On the IDE side, obviously at Microsoft we've got the Solidity interface into Visual Studio. Visual Studio Code works great with Truffle. There's Mix and Cosmos. You can download Ethereum Studio, which is kind of a self-contained apparatus for dealing with things. You can even work with good old Atom, which there's a lot of similarities between Visual Studio Code and Atom from an interface, but you can go all the way down low level for the folks that really want to get hardcore. They can write this stuff in Emacs or in Vim, and there are even extensions for those two tools to allow you to write good old smart contracts.
Yeah, and just to mention on the Cosmos, when there's this, it's basically the online Solidity compiler, and the interesting thing there is you don't even need an IDE. So the IDE is in the browser. So you basically just go to a website and you have an IDE there, so you can start writing smart contracts, compile them in the browser, and you can actually deploy them to blockchains.
So that's really great because it's a real smart, real quick way to get up and going and playing. If you want to start with a hello world, you can go out to Cosmo, do those kinds of things. But do they have production instances of that where you download it, or is it all just you go to Cosmo and there it is and it's a web interface and you can do your whole tooling from that point?
Yeah, it's open source, so you can obviously pull that thing down and bring it inside your enterprise walls if that's what you're looking for. But yeah, I think the idea there is really, I want to try something out really quick. Yeah, let me just go try this, and you can actually just like copy and paste that into Visual Studio or Truffle or any of these other ones like later and say, here's my Sol code, my Solidity code.
So let's talk about some of those frameworks.
Yeah. So basically, I'll walk through a couple of these most popular ones. I'll talk about BlockApps here a little bit first. And what I did is kind of broke these out and showed you kind of like, even from like an OSI model, like what do these things look like, the different layers that we're working with here. So when we're talking about building something on top of BlockApps, we're talking about at the foundation level, the blockchain we're going to be using is Strato. So you can think of BlockApps. They basically have two different SDKs. You can see them on the slide here. The one in the middle says BlockApps/JS, and then it has /Xamarin. So BlockApps.js is a library that you can pull down. It's a node-based library. You can pull it off NPM. It's up there in the public repository. And then there's also one that's just called Block. Now, I'll talk about the differences between those two in a second, but both of those things are basically built to be a wrapper around Strato.
Okay.
I mentioned that Strato is an API that sits on top of a blockchain. You can think of it just like Azure, right? Nobody, or very few people I know of, are actually writing directly to the API in Azure. They go grab an SDK that we built in whatever language they're comfortable with, and then they use that thing to actually make the REST calls that's actually going in because they're quite complex. Same thing here. So you can actually interface directly with Strato if you wanted to from your application, or you can start laying these other things on there, and it builds more rapid development environment. So it allows you to build faster.
And that's nice because BlockApps, not only do they have the SDK, they also have the underlying chain structure itself.
Correct.
And so that's not Ethereum running down there. That's not Bitcoin running on it. It's its own thing.
Correct.
And so they've got, it's kind of a first-party integration story that they've built on that.
Yeah. And what I'm showing here, so we have the SDK there with BlockApps.js. Now, Block has a dependency on BlockApps.js. So Block, you can think of it as like a CLI, but it can even be beyond that. I see a lot of people actually building on top of it. So it's a very, if you think about the REST API at the Strato level being complex, this is a very kind of, think about it as a dumbed down version. I want to create an account. I want to upload a contract. I want to execute a transaction. I mean, just the core things that you want to do.
Basic stuff. Yeah.
Very simple API. This is what Block gives you. If you want to go a step down and say, no, I want to talk directly to BlockApps.js and do maybe a couple more advanced things, you can totally do that.
Okay.
Block just makes it easier, you know. So I put Block up there at the top. You can have your dApp actually point to Block, which will call down and through into Strato, or you can have your decentralized app talk to BlockApps.js directly. Slightly more code, a little bit more complex, but you can get a couple more features if you do it that way.
It's a little, yeah, the trade-off is it's a little more verbose, a little more complex, but you're going to get the additional features that that SDK provides on top of it.
That's correct.
Yep.
Another one, and we'll move on here to Truffle. So we've been mentioning this a lot. It's got a lot of traction out there in the industry. It's a very nice set of tools built by Tim Coulter primarily. It's an open source project. And essentially, they're slightly different, right? So they're talking to both public Ethereum, private Ethereum. I haven't marked as Azure here, but you could run that on any infrastructure.
We prefer Azure.
We prefer Azure.
Yeah.
But yeah, and testnet as well. And so basically, this can talk to any of the public or the standard Ethereum interfaces. And so you have the Truffle SDK, and then you have these clients that are going to work with it. Now, one thing to think about here is I put TestRPC up here at the top. TestRPC basically emulates a blockchain. So you can think about that when you start developing. It's in memory. It's almost like an emulator, right?
Okay.
So basically, you're going to fire this TestRPC thing up. It's going to create some accounts for you, and you can pass parameters and kind of customize it. But by default, it would give you like 10 accounts.
Okay.
And then you can just basically hook up your dApp that's up at your top level. You can start talking directly to the blockchain through whatever client tools that you want. Yeah.
Okay.
And you can start simulating it, running your workloads, make sure everything works. Again, has nothing to do with blockchain. It's instant. So you're not having to wait for mining and all that kind of happy stuff to happen. It's really good for developers. And then once you're done, you say, okay, everything works. We can replace the pointer to TestRPC with the actual blockchain.
And this is really good because when I was learning it as a noob, this is the exact framework that I started with was Truffle. I ended up with TestRPC. I used Truffle to help me scaffold some things, and then built my very simple app around that and was able to instantly deploy. I didn't have to worry about creating a big consensus network and things like that. When it was done, I took my Solidity files and I just ported them over and deployed them into Mist, into the Mist browser, and off it went.
Yep. A great tool. Yeah, you should take a look at it, and we'll do some demos on it. And then the last being Visual Studio. So this one, again, is kind of a partnership that we were working with Consensus, but we're starting to expand this as well now to support other chains. But the initial one here was to basically say, how can we make it super easy for someone to just come in and start building a dApp and upload a smart contract and get the thing actually running? Because as Derek mentioned, it can be frustrating a little bit when you first start and all this stuff's new to you. figuring out, okay, I need to have these 3 things running. How do I make sure I got everything
You don't have to
running the right
talk,
way?
and there's IPC stuff going on, and
ports and everything involved, and you're like, okay, this is too much. I'm kind of going to give up here. I don't know what's happening. So what we did is said, okay, can we build on top of what the guys did at Block, and basically build that into Visual Studio? So what we did is took Solidity as a language and put that into Visual Studio. So now you have an authoring environment where it has, text highlighting and spacing and all that kind of normal stuff that you'd expect in an IDE. And then on top of that, we can do the compilation inside Visual Studio. So as you do a compile, you'll see the output actually come into the output window in Visual Studio. You can see if you make a mistake, it'll actually give you the output back from the Sol C compiler. So you can actually see like where you made your mistake.
Oh, great.
You can fix it.
Okay.
And then you can basically, by default, without even touching anything, you just right-click on that contract and deploy it to Azure.
Okay.
So that's really cool because you didn't have to do any infrastructure. So me as a developer, maybe I come in there and I say, that blockchain stuff's really cool, but I don't even want to think about
just a JavaScript developer. Yeah, I'm just a JS guy. Yeah.
So just give me a blockchain that I can hit like test RPC or something of that nature. And so what we did was said, okay, well, we already have an instance running out there, like a dev instance that we can use publicly. We can just point to that. And then if you want to move it to a private instance, spin up your own Strato instance in Azure and just change the pointer in your config file.
Fantastic. Love it.
So that kind of wraps the module on actually building and development of these dApps. We're going to talk about some of that in the architecture and development, and we'll show some demos on this as well.
We like demos. All right. We'll see you guys later.
Thanks.